Instruments and warning lights must be provided for the pilot to monitor the aircraft DC electrical system. These normally consist of a voltmeter, an ammeter or ammeters, and a light to inform the pilot that the generator is not online. In this lesson, we will look at these instruments and warning light, and we will examine the indications the pilot can expect to see during system operation. An ammeter is used to measure the current flowing in the electrical system. In order to do this, the ammeter has a low internal resistance and is placed in series with the load or loads. The ammeter is normally a moving coil type of instrument. The instrument consists of a permanent magnet with a soft iron core between the poles. A former on a spindle is free to rotate inside the magnetic field. A coil of wire is wound around the former, and current is allowed to flow through the coil. Two hairsprings are fitted to restrain the movement of the coil. As the coil rotates, one spring is wound up, the other unwound. The coil and former carry a pointer, which is arranged to move over a scale as the coil rotates. The meter is likely to be housed inside a case made of soft iron, to prevent stray magnetism affecting the indication. When current flows through the coil, a magnetic field is created, which interacts with the field from the permanent magnet, causing the field to be strengthened and weakened in the areas shown. This causes the coil to rotate, moving the indicator pointer across the scale until the magnetic torque is balanced by the hairspring. The greater the current flow through the coil, the greater will be the movement of the pointer. The deflection of the pointer is proportional to the current flowing through the coil. When the current flow reduces to zero, the pointer will be returned to its zero mark by the hairspring. To enable the range of the instrument to be extended, a resistor of low resistance value, known as a shunt, can be fitted in parallel with it. A known proportion of the current will flow through the shunt, with the remainder flowing through the ammeter. The scale is suitably calibrated to indicate the total current flow. The number of ammeters required and the type employed depends on the type of aircraft and the overall nature of its electrical installation. One ammeter is normally provided for each possible source of power. There are two types of ammeter in common use. They are the charge, discharge, or center zero ammeter and the left zero ammeter. The charge, discharge, or center zero type ammeter displays information about current flow into or out of the battery. If the needle is to the right of zero, the generator or alternator is working and supplying power to the electrical system and charging the battery. If the needle is to the left of zero, then the battery is discharging, indicating that the generator or alternator is not supplying power to the electrical system, and that the loads are being supplied by the battery. The left zero type of ammeter displays the actual current being drawn from a generator or alternator. This type of meter is often referred to as a load meter. If the load meter reads 0, then the alternator is not supplying power to the system, leaving the battery as the sole source of power in a single engine system. The electromotive force, or potential difference, between any 2 points in an electrical circuit can be measured using a voltmeter. The voltmeter is a moving coil instrument and is constructed in a very similar manner to the ammeter. The difference is that the voltmeter has a very high internal resistance and is connected in parallel to measure the voltage between 2 points. The voltage of a buzz bar, for example. A voltmeter may have a high resistance resistor, known as a multiplier, fitted in series with the meter, to increase the indicating range of the instrument. The multiplier will reduce the current flow through the voltmeter by a known proportion, allowing the gauge to measure higher voltages without being damaged. A typical DC system will have a single voltmeter, which can be selected to display the voltage of the generator, the buzz bar, or the battery. The generator, or alternator warning light, indicates to the pilot that the generator or alternator voltage has fallen below the battery voltage. Illumination of the light is usually associated with a generator cutout, or with the operation of a reverse current detector. We will now take a look at the indications the pilot can typically expect to see during the various phases of an aircraft's operation. Prior to engine start, with the battery switch to off and the voltmeter selector to off, all 3 gauges will read 0. The generator failure warning light will not be illuminated, even though the cutout is open, because there is no power available to operate it. The pilot moves the voltmeter selector to the battery position. The battery voltage is now indicated on the voltmeter. Next, he selects the battery switch to on, connecting the battery to the buzz bar. The battery will now supply the loads, and its center zero ammeter will indicate a discharge. Because there is now power available to it, the generator failure warning light will illuminate. When the engine is being started, the load on the battery will be greatly increased. This will be displayed as a high discharge reading on the battery ammeter and a drop in battery voltage. The voltmeter selector switch is now moved to the generator position, so that the rising generator output voltage can be monitored. When the generator output voltage rises above that of the battery, the cutout will close, and the generator failure warning light will go out. The generator will now supply the loads and begin to charge the battery. Initially, the charging current will be high, in this case approximately 30 amps, as indicated as a charging current on the battery ammeter. This, and the 10 amps being taken by the loads, is indicated as a 40 amp load on the generator load meter. As the battery becomes recharged, the charge current will drop off to a trickle, and this will be reflected on the generator load meter. If the generator should fail, then its output voltage will fall to 0, and the cutout will open, bringing on the failure warning light. All of the loads are now being supplied by the battery. The pilot must therefore immediately assess the situation to determine what equipment is essential to the safety of flight, and turn off everything else to conserve battery power. This procedure is known as load shedding. Items that could be turned off to conserve power would include heating or cooling fans and unnecessary lighting. That is the end of the lesson. Here are the main points that you should remember. An ammeter is a moving coil instrument, which is used to measure the current flowing in a circuit. Battery ammeters are usually center zero in their operation. After engine start, the battery ammeter will show a high charge rate for a short period, until the battery recovers its charge. Generator or alternator ammeters, often known as load meters, are left zero in their operation. A moving coil voltmeter is used to measure the voltage applied in an electrical circuit. There is normally only one voltmeter which can be switched to measure the voltage in various parts of the circuit. The generator or alternator warning light indicates to the pilot that the generator or alternator voltage has fallen below the battery voltage. In the event of an in-flight generator or alternator failure, non-essential loads should be shed as soon as possible, in order to conserve battery power.